Good morning and welcome to Fundamental Mathematics. I'm your host, Dr. Turner. Today we are looking at 6.3, which is looking at scientific notation. There are a lot of things we can talk about in scientific notation. What is scientific notation, how to convert, when it's used, why it's appropriate, how to compare values that are either in scientific notation or regular notation. These are all things that could potentially come up on a standardized test. For the fundamental class, we're going to focus on what is proper scientific notation. And then from there, we're going to talk about in 6.4 and 6.5, converting between the two. Okay. So first, what is scientific notation? Scientific notation is a way of writing either really big or really small numbers. So when you look at something like the distance from the Earth to the sun, or the width of a cell, or the width of a mitochondria, or something like that, you're looking at very, very small and very, very big numbers. And when you get a very large, very small number, a lot of the zeros that are there are essentially placeholders, but it makes the number sort of hard to read. And so a way of condensing that is writing these numbers in a way that is easy to see what we call the significant digits or significant figures, and ignoring the zeros that are just acting as placeholders. So when you write a number in scientific notation, it is going to look something like this. You're going to have a number out front. In some textbooks, they'll refer to that as the index, but more commonly, it's known as the coefficient. And it's always going to be multiplied by 10 to some power. And this gets into exponents, which we'll also review here in later units, but 10, that is your base. For scientific notation, your base will always be 10. And then the power up here, the number up here, that is your exponent. So a couple of things on this form. First and foremost, when you go to fill in the coefficient, if it is in proper scientific notation, the coefficient has to be between certain values. Specifically, it has to be greater or equal to 1, or it has to be less than 10. Now, there are two different symbols here that I'm using. The first is less than or equal to. That means it can be 1 or higher than that. Whereas the other symbol means it needs to be less than 10. So I can never have a 10 if it's in proper scientific notation. It needs to be less than 10. It could be 9, it could be 9.9, it could be 9.999. But if it's not between 1 inclusive and 10, then it's not in correct scientific notation. Why is that important? Well, you will have some assignments or questions on standardized tests that simply ask you, is this in correct scientific notation, yes or no? It's also important because if you go to compare values, which you will do, especially as you get into later science and math classes, you'll have to compare values that are in standard and scientific notation. You'll have to do operations with numbers that are in scientific notation. And sometimes it'll end up in a form that is not between 1 and 10. And then the question is, okay, well, how do you convert from this almost scientific notation to correct scientific notation? That's a little bit above our pay grade for right now. We just want to know, is it in correct scientific notation, yes or no? So for your assignment from my class for 6.3, you're literally going to have a sheet of questions. And the question is it correct scientific notation, yes or no? Okay. So again, what you're looking for is for the coefficient to be between 1 inclusive and 10. The base has to be 10. And the exponent can be literally anything. So number 1, 6.5 times 10 to the third power. Check, my base is between, my base is 10. My coefficient is between 1 inclusive and 10. And I have an exponent. Yes, that is correct scientific notation. Number 2, 6.7 times 10 to the negative fifth power. Again, what am I checking? The coefficient is between 1 inclusive and 10. I have a base of 10. I'm golden. That's all I need for it to be correct scientific notation. Number 3, 0.7 times 10 to the 8th power. Check it here. My coefficient is not between 1 and 10. So that is not correct scientific notation. Number 4, 3.0 times 10 to the 0 power. My base is between 1 and 10. All right, my coefficient rather is between 1 and 10. My base is 10. I'm good. That's correct scientific notation. Your coefficient can be anything. Typically, it's going to be an integer, but it can be 0, it can be negative. That doesn't change the correct scientific notation. Okay. Number 5, 1.0 times 10 to the 13th power. My base is 10. I look at my coefficient. That is between 1 and 10. Remember, 1 can be included, but not 10. So yes, that is correct scientific notation. 6, 10 times 10 to the 5th power. Here, remember that it is less than 10. So 1 can be included, 10 cannot. So in this example, no, that is not correct scientific notation. That's all you have to do for 6.3, just identify, is it correct scientific notation or not? That's all for today. If you have any questions, please reach out during office hours. Otherwise, have a good day. I will talk to you soon. Bye.